Okay, on Wednesday, all this stuff will be on there. Yesterday, we did a show and tell. Okay, as you go down the alkali metals, what group are those in? Group number 1. You better know that. That was a question or a quiz. So as you go down, what happens to the reactivity of the alkali metals? It does not decrease. It does the opposite of decreasing.
Increases.
It increases. Go find sodium on the periodic table. Na. Go find sodium. Okay? If I drop sodium in here, what's going to happen?
It's going
It's going to instantly react. It's going to generate lots of hydrogen gas, may even spark. Who knows? Okay? Can never be, can't really tell when. It's difficult to tell, it's difficult to predict. Alright, so as soon as I move to the right and I go to calcium, then what happens? Anything spectacular?
No.
No, a lot less spectacular. Okay, why? Because as you go to the right, what happens to the reactivity of metals?
It decreases.
It decreases. So as you go down the periodic table, what happens to the explosivity of metals? It increases. And if you go this way, what happens? It decreases. Okay, that is true all the way pretty much through the transition metals. Go find gold in the periodic table. Go find the element gold as in monies, as in treasure, as in kings and queens. Why did human beings choose to make monies out of gold?
It's not reactive.
It's not reactive to the atmosphere. It stays shiny through generations of human beings. You can inherit fortunes of gold. What if our money was based on iron? Well, in a couple generations it'd be gone. It'd be rusted. Okay, so copper, gold, and silver, they react very slow, Robs. Because why, Rob? As you go down this way, what happens to the reactivity as you go across?
It decreases.
It decreases. But then, folks, then something happens when we get to the halogens. Okay? I'm over here. Hello, I'm over here. Something happens when we get past the metalloids. Okay? Well, then we don't have metals anymore, do we? Now over here we have nonmetals. You see that, Rob? Okay. So yesterday did I show you the video of a brick being set on fire?
No.
I did not. Well, I'm going to show you a video of a brick being set. How many of you have ever seen a brick oven just catch on fire and burst into flames? How many of you have ever seen a brick burst into flames? Okay?
That's so weird.
So brick burning by fluorine. Everybody go find fluorine in the periodic table.
Number 9.
Okay. So fluorine is actually extremely, extremely dangerous. But wait, don't we brush our teeth with fluorine? No, no, you brush your teeth with sodium fluoride. Okay, you brush your teeth with a compound. Fluorine's an element. Okay, so if you have fluorine, the elements coming out of this tube right here, contacting that brick, it's going to light the brick on fire and burn it, Rob, just like it was a log. Okay? You ever seen a brick be burnt like it was a log?
No.
Well, there it is. That's not a welding torch, class. That's fluorine gas coming straight out and igniting a brick and burning it.
Will it do that to me?
Okay, I've never seen that happen in real life, neither have you. But if we had some fluorine gas, that is exactly what would happen. Fluorine gas would burn everything. Okay? So yes, if you put fluorine on a wood, on logs, it would just go up in flames. Fluorine absolutely kills and destroys everything. Just like the alkali metals, cesium and francium would, or cesium and rubidium. But what's the difference? Fluorine's not a metal, it's a what? It's a gas, it's a non-metal. Okay, well, you know what else is very, 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 very reactive? What's something that sets things on fire and makes them rust?
Oxygen.
Oxygen. Oxygen is extremely reactive. It blows things up, Rob. It's the reason why you have body heat. The oxygen is burning the food you ate today, burning the taters you ate today, and because of that you have body heat.
I don't think I ate taters today, though.
Pizza.
Yeah.
Okay, how many of you swam in the pool with the chlorine?
Oh, yeah. Me.
Why did they put chlorine in the pool? To kill all bacteria. If you drank some bleach, would it also kill you as well as the bacteria?
Yeah.
It would also will kill you as well. Yes, I know, Rob. Okay, so now, here's what you need to write down. Here's what you need to escribe on your paper.
I got you.
Okay? The most reactive non-metals in the periodic table. Most reactive non-metals in the periodic table are fluorine, okay, oxygen, and chlorine. So as you go up, what happens to the reactivity of elements on this side? They get more explosive. Okay? So chlorine is more explosive than fluorine. Chlorine's more explosive than fluorine. Okay? Oxygen's actually more explosive than fluorine. So as you go up the halogens and up the nonmetals, they get more explosive. How's that differ from over here and over here, what happens? If you go down, they get more explosive. So when does that flip, Charles? When does that flip, man? When you get past the wares. The metalloids. So when you get past the metalloids, it flips. Okay? On this side of the periodic table, as you go down, they get more explosive. As you go across, they get less explosive. But then when you get to the metalloids, okay, it flips. The nonmetals are kind of the opposites. Now, having taught you all that, Dr. Mann, what are the two most massively explosive groups, columns of elements in the periodic table? What would you predict? What would you think? What would be your opinion? Your guess. Charles, what do you think? Out of all the groups in the periodic table, which two groups are the most explosive in the whole periodic table?
Alkali metals.
And?
Halogen.
That's exactly right. So group 1 and 17, that's what you need to write down. Group 1 and group 17, by the way, which way do groups go, class? Go this way. Columns of groups, there's 18 of them. Group 1 and 17 are the most reactive groups, period. Period with a period. Write that down, class. All of you. And Cody. And Isaiah. And Gabriel. Groups 1 and 17 are the most reactive. Now check this out. What would happen if something from group 1, like I don't know, maybe sodium, were to come in contact with group 17 here, chlorine? What would happen?
A big kaboom.
You would have a massive, massive kaboom.
That would not be good.
You know what?
Period.
Yeah, that would be a massive boom. You know what you would have after that?
Radiation. Salt.
Nothing.
Salt.
Wow.
So if you took pure sodium
Radiation.
and you reacted it with chlorine, they would go kaboom, and you would get salt. Is that how salt got formed? No, not really. Okay? But you would have salt. That's what would happen. You would have a massive, massive explosion. Group 1 and group 17 are the most reactive in the entire periodic period. You know what's the most unreactive in the whole periodic table? The most unreactive group. Yes. Good, Chicago. The noble gases.
You wrote that.
The noble gases do nothing.
Oh.
They are inert. You ever heard of inertia, Rob? What's that mean, inertia? Something has inertia. Objects at rest stay at rest?
Yes.
Well, that's where the term inert comes from. It comes from inertia.
It's unreactive.
It's unreactive, it doesn't do anything. They don't explode, they don't do nothing. Okay? Alrighty. Now, you need to know that for the test?
Yeah.
You do need to know that for the test. Okay, here's what else you need to know. Coming over here. Atoms, as you go across the periodic table, you know what happens to them? They get what? Smaller. Okay? They get smaller. So everybody flip to page 188 real quick. Go to page 188. How much of this did we do yesterday?
We did all of it.
We did it all right.
All of it.
Well, I'm going to do this again. Okay, so they get smaller, they decrease. As you go down, they increase. Okay, what's the smallest atom on the whole entire periodic table? Helium is. hydrogen actually, Rob, it'd be helium. Okay? That's atomic rating. Okay? Now, flip to page 190. Page 190, 191. Cody. Cody. Ionization energy.
We got who?
Okay? What's an ion? What's an ion class?
As a plus.
Yeah, it's positive or negative. So it has a different number of electrons, right? Right, Ms. Johnson? So, the ionization energy, okay, David Bowie,
Yes, sir.
means the energy it takes to pull off an electron. Okay, I want to make it a positive ion. If I want to make it a positive ion, I got to pull electrons off. So as you go across the periodic table, hey, man, as you go across the periodic table, it's more difficult. More difficult. Write that down, Rob. More difficult. Okay? More difficult.
Oh wait.
And as you go down the periodic table, it gets easier. Gets easier.
Which one? Which one do I write this on?
This is ionization energy, sir. Ionization energy, man. Okay.
Oh, okay. Okay.
Well, Nathan, doesn't that prove, like, when we went down the alkali metals, they explode more?
Yes.
Yes, it gets easier to explode. That's called ionization energy. Easier to make explode. As you go across the periodic table, look what we just did. We did sodium, we did calcium. Okay, we went across the periodic table. Did they explode more or did they explode less? Less. So that means ionization energy becomes more difficult to make it explode. They explode less. Right, Jessica? Okay. Now, the nonmetals over here, group 17. Right? Wait, group 17. What's the most reactive nonmetals? Which ones? Fluorine, oxygen, and chlorine. Right? Okay, you know why they are like they are? Like why it flips over here? Like up top over here? It's the most reactive up top. I mean, the rest of the periodic table, it's more explosive down here. See, Robs, it's more explosive down here for the rest of the periodic table. Yeah? But up here, over here, right, it's up here. These don't explode. It's up here. You know why it flips?
The atomic.
Because these guys like electrons. These guys do not like electrons. Okay? These guys like to get electrons. These guys like to give electrons. These guys get, these guys give. Get, give. Getting, giving. Get electrons, give electrons. Are you listening to this? Whitney?
Yes.
Whitney, which ones like to get electrons? Metals or nonmetals? Nonmetals like to get. Which ones like to give? Metals. Nonmetals get. Metals give. Get, give, give. Get, give, give. Take, give, give. Take electrons, give electrons. Alright? You understand? Okay, now over here now. The taking of electrons is called electronegativity. The ability of an atom to attract electrons in a chemical bond. Fluorine loves to get electrons. Fluorine loves to get them the most. You know who loves to give them the most? I won't use francium as an example. Cesium does. Francium there's no francium anywhere found. It just, there's 5 atoms in the earth somewhere. Cesium loves to give them away. Okay? Give, take, take. Give, take, take. Okay? So, take, give. Rob, do alkali metals take electrons or give electrons?
They give.
They give. Blake, do halogens give electrons or take electrons?
Halogen,
They take. And then trick question, Dr. Mayer, what do noble gases do?
Nothing.
Nothing.
They don't do
They
anything.
don't do anything.
They don't participate in all this crap.
They're like Russia. They don't do
That make sense? Nathan, does that make sense?
Of course it does.
Nathan, while you were playing baseball,
I was playing
do alkali metals and alkali earth metals, do they give electrons or do they take electrons?
They take. No.
No, they freaking
Oh
give.
my god, I don't have my glasses on.
They give electrons. Okay, what about the nonmetals? What about oxygen, fluorine? What do they do? They take electrons. Everybody hide up, everybody hold up a giant periodic table.
Oh no. Hold it together.
Okay, here we go. Everybody point at the nonmetals. Where's the nonmetals? Where's the nonmetals? No, Rob, they're not down there. Where's the nonmetals, man?
It says green.
Yes, it's green, but it's also brown too. Alright, what about those? Do they give or take? Take. Alright, everybody point at the metals in the left corner. Alkali and alkali earth. What do those do?
Give.
Give electrons. They give electrons. Okay? Alright, so what we're going to do for practice now is we're going to concentrate on radius. I'm going to give you some elements that you have to put in order, from smallest to biggest. Okay? Over here, 9. Over here, 9. Here we go. Go to a new page. Everyone. Everybody go to a new page. New page, everybody. New page. Okay, you have the elements aluminum, and then you have an element magnesium, and then you have an element oxygen, and then you have an element helium. I want atomic radii. I want it from smallest over here to largest over here. Which one of those 4 atoms is the smallest? What?
Helium.
Helium's the smallest. Okay? And then remember the alligator always eats more? Remember the alligator always eats more? Remember that? You guys didn't learn that in elementary school?
No, I did.
Yes.
Yeah,
Wait, it's a River and Mustang sign. The alligator always eats more. What's the next biggest? What's the next biggest? Oxygen. Rob, what's the next biggest?
Is it what did you say? Is it the MG one?
No, sir.
So it's aluminum.
It's aluminum. Why? Because the size of the atoms decreases going this way. And then finally Mg. Okay?